Hello everyone, welcome back to Smart Industry YouTube channel. Myself Jagamohan. Today we are going to discuss biweekly contest 134 first three problems. Okay, so let's quickly jump into the first problem. Let's go through problem statement. So the problem statement is there is a circle of red and blue tiles, and you are given an array of integers colors. Okay, so simply you are given colors array, integer array. Okay, let's say the size of the colors array is 8, and it is in circular with red and which contains red and blue tiles. Okay, so colors of I equals to 0. Colors of I equals to 0, that means it is red. If colors of I is 0, then that means it is red color. Similarly, if colors of I equals to 1, that means it is blue color. Okay, so simply your array contains zeros and ones. Now let's move forward. Every three contiguous tiles in the circle with alternating colors, the middle tile has a different color from its left and right tiles, is called an alternating. Okay, so simply alternating group is nothing but let's say you're having three contiguous tiles in this fashion. Okay, or in this fashion. So these we call it as alternating groups. Okay, this we call it as alternating. So it should be contiguous, three contiguous colors, and the alternating color should be different. Okay, everyone clear till now? Now, what we should do is we need to return the number of alternatives. Okay, and there is a note as well that since colors represents a circle, the first and the last tiles are considered to be next to each other. Okay, so whatever array is present, this we are considering it as circle. So the next color that comes after the last tile is zeroth index value, and the value before zeroth index is nothing but, let's say the array size is n, that will be nothing but n minus 1. Okay, so if you observe this diagram, you will understand it clearly. So simply this is 0, since it is 1, it is in blue color. Same with 1 and same with 2. Okay, so after 2 what comes? 0 will come, and before 0 what will be there? 2 will be there. Okay, now let's move to next example, and this is the other example. So you are given arrays colors. Let's say the size of array is n, and this is the given array. Okay, now you need to count number of groups. So simply if you observe this diagram, okay, this is nothing but it's representing the circular representation of this array. Okay, where 0 is red and 1 is blue, and whatever the values present in this are nothing but those indices. Okay, so this is 0 index, this is first index, this is second index value, and this is third index value, something like this. Okay, so can you simply tell me how many alternating groups you can see in this diagram? So let's say if we start from 3, if we start from 3, there is one alternating group. Okay, and if you start from 4, there is another alternating group. Similarly, if you start from 0, there is another alternating. So total how many groups? Nothing but 3 groups. Okay, so how can we solve this problem? So firstly, let's say you are having 3 contiguous values. Generally, how will you identify whether it is alternating group or not? Let's say you are given 0 0 1. Can you simply tell me whether it is alternating group or not? With the help of this middle element, can you say that? Yes, sir. If it is 1, you can simply say it is alternating. Similarly, if you know this value, you can simply compare with previous and next, and then you can say whether it is alternating group or not. Yes, sir. So simply When you are here, so as of now, let's say I divide it into two parts. One is the values that are leaving the corners. Okay, that is nothing but let's leave zeroth index value and n minus 1 index value. Let's try to count number of alternating groups in between. Okay, that is nothing but 1 to n minus 2. So firstly we'll count that. We'll count this part. Then we will bother about these two columns. Okay. So firstly, how will you count this? Simply you start traversing from index 1 and you traverse till n minus 2. 1 to n minus 2. You keep traversing, and every time you simply check with the when you're at this index, you will simply compare with previous element and next element. And if the current element is not equals to previous and next element, simply you'll maintain some variable. Okay, let's say you're counting groups, you're maintaining a variable initialized to 0. Every time you will compare, whenever you came across alternating group, you will increment it. And when you are at this index, you will compare with previous and next. Since the next element is same as current element, it can't form an alternative. Similarly, when you are here, you will compare with next and previous. Okay, so this way you will count the number of groups for these values. And what about corners? What about corners? Can I simply say what is the next element for 4? That is nothing but 0th index value. Yes or no? Similarly, what is previous element for 0? Can I simply say n minus 1? Yes or no? So let's say if the previous element for 0 is same as 0th index value, or the next element for n minus 1 is same as n minus 1, can they form a group? Let's say instead of 0, if you're having 1, since the next element for this is 1 and the previous element for this is 1, will it make any sense? No, right? So for corners, simply what you can do is, firstly you can check whether these both are not equal or not. Okay, you can simply check colors of 0 is not equals to colors of n minus 1. Then only there is a possibility for the corner cases to form. Okay, so for colors of 0, you compare it with previous element. Then now you should take care of next element. Okay, if this condition is satisfied, you should just take care of next element. If next element is also not same as current, then you can increment the count. Same for n minus 1. You compare with next element, which is 0th index value. If these both are not same, you should simply take care of previous element. Okay, if previous element is also not same as n minus 1, then again you can increment groups. Okay, now I hope everyone is clear with the approach. Let's jump into problems. Okay, let's write code first problem. So initially, what is your approach? Simply, first let's take size of the arrays and let's take some variable groups for storing the answer, and let's initialize with 0. Now, first take care of middle elements. That's nothing but for int I equals to 1 to I less than n minus 2. Okay, we're traversing from 1 to n minus 2. So every time, what we'll be doing, if current value, that is nothing but colors of I, not equals to previous value, that is nothing but colors of I minus 1, also, and then colors of I not equals to colors of I plus 1. Okay, then what we'll be doing, we should increment groups. Now, what's the case that we are missing? Simply, if colors of 0 equals to colors of n minus 1. There is nothing we can do. What if they both are not equal? Then simply what we should be doing for colors of 0, we already checked with previous element. What is the previous element? N minus 1. Now we should compare with next element. So when colors of 0 not equals next element, that's nothing but colors of 1. Then we can simply increment groups. Also same for colors of n minus 1. So for n minus 1, you compared with next element. Now you should compare with previous element. Colors of n minus 2. Groups of, you can increment group. Then simply return groups. Now here if you observe, we are trying to access from 0, we are trying to access 1. Similarly, from n minus 1, we are trying to access n minus 2. But is it possible? Yes, if the colors length is 1, then it might not work. But the minimum value for colors length is 3. So these conditions will work. Okay, let's run the code. Okay, let's submit. That's it. Now let's start with the second question. So the given problem statement is you are given an integer array in minutes, okay, denoting the energy values of the various elements. Also, you are given an integer current energy, denoting the amount of energy you have initially. Okay, you start with 0 points, and all the enemies are unmarked initially. Okay, so here you are given an array named enemy energies. This is an integer array. Let's say the size is n. Let's say the size is n. Also, you are given an integer current energy. Okay, along with this, you will be having points which are initially 0. Okay, so this is the given information. At the same time, whatever the enemy energies you are having, those are all unmarked. So what is this unmarked? Let's understand. We will understand it later. Let's move forward. Now, you can perform either of the following operations 0 or multiple times to gain points. Okay. So now what you are going to do is you're going to perform operations. Okay. You can perform either of the following operations. Why you are performing those operations? To gain points. And how many times you can perform those operations? Either it is 0 times or multiple times. If you consider an array element, you can perform that operation either 0 times or multiple times. Okay, and why you are doing it? To gain points. So let's see what are those operations. First operation is choose an unmarked element. So can you tell me, let's say all these elements are present in array, what uh, what are eligible elements that you can pick? So first criteria is unmarked enemy. So all the elements are unmarked, so you can pick any of them, such that current energy should be greater than enemy elements. So first criteria should be unmarked, and our second criteria should be current energy. Let's say you're having some current energy as 10, and your array elements are okay. So can you tell me what elements can you pick? What are eligible elements that you can pick from the array? So your current energy should be either greater than or equals to enemy energies. Okay. So can you pick 15? No, you can only pick either 2 or 3 elements. Yes, sir. So this is the condition. Now, if you perform this operation, what happens? You will gain 1 point. Let's say you're picking 2, or let's say you're picking 3. And when you're applying this operation, what happens is your points will become your you're picking 3, your points will become 1, and your current energy will be reduced by that particular enemy's energy. Okay, so your current energy will become 10 minus 3, that is nothing but 7. Okay, everyone clear? Now, let's see what is the second operation. So for second operation, if you have at least 1 point, okay, so for applying second operation, you need at least 1 point. Okay, so that is the first criteria. Now you can choose an unmarked element. Same, you can choose one unmarked element. Now by choosing the option, what happens, we will see. So you're having 7 and your points are 1 and you're having unmarked enemies in the air. Yes, so now what you can do is, by choosing that, you can pick pick one element. Let's say I'm picking 9. What I should do is, I can add that energy to my current energy. So that is nothing but 7 plus 9. So I can add that and this will become 16. And the second thing, I will mark this enemy. Okay. So in second operation, what you are doing, you will simply pick an unmarked enemy. You will add that energy to your current energy and you will mark it. And for that, the basic criteria should be, you should have at least 1 point. Okay. Point should not be 0. Now, what you should return? You should return an integer denoting the maximum points you can get in the end by optimally performing operations. Okay, so you need to return the maximum points that you can achieve. Okay, by performing these operations. So let's see few examples so that we can understand better. Hmm. Let's see the first example. You are given arrays. I am writing it in short form. Don't get confused. Enemy energies. Let's say the size is n. So this is the given array. Okay, and you're also having some current energy, and current energy, given current energy is 3, and initially you'll be having points which is nothing but 0. Okay, so every time what you can do, and also all the array elements are unmarked. Okay, so simply what you can do, you can pick an element, then you can subtract from current energy. Now what will you pick? Firstly, what operations can we apply? Can we apply first operation? What's the first operation? You should pick some unmarked enemy. Okay. Here you are having 3 unmarked enemies, and the strength of the enemy should be less than or equals to current energy. So if you consider these three elements are having either equals to or less than current energy. So you can pick any of them. Okay. And can we apply second operation? For second operation, what is the basic criteria? It should have at least 1 point. Okay. So we can only apply first operation. Now what will you choose? So keep this in mind when you are choosing an enemy, its energy should be as minimum as possible so that your current energy will be maximized. Okay, if you pick 3, what happens to your current energy? It will become 0. If you pick 2, your current energy will become 1. So let's say I pick the last element, that is nothing but 2, and this will become 1. My current energy will become 1 and my points will be 1. Now, can you tell me, can I apply first operation? My current energy is 1. I'm having okay, just give me a minute. I'm having unmarked enemies. But if you observe my current energy, all the enemies are having more than current energy. So, so we cannot perform first operation. What about second operation? What is the first basic criteria? The point should be at least 1. So 1 point is there. Now you should have unmarked enemies. You are having unmarked enemies. Now you should choose an enemy such that your current energy will be maximized. Yes, sir. So which enemy you will choose? Definitely 3. You will pick 3 and this will become 4. Okay. So simply you will pick 3, you will add it to 1 and this will become 4 and this unmarked will become marked. Now again, can you apply you can apply first operation? Yes or no? So simply what you will be doing, you will pick one unmarked enemy, you will subtract it. Okay. So your points will become 2 and this will become 2. Okay. Now what you will be doing? Again, you should keep applying the operations, and let's say, so here current energy is 2, but I took it as 3. Got it? So what happens? Again, you will pick another enemy. Okay, you will subtract it, it will become 0. Okay, and your points will be 3. And again, you will apply second operation, you will make it marked. and your current energy will be increased by 2. You'll add 2 for this. Then again, you will pick an enemy. You will make it, you will subtract that energy. It will become 0. Then your points will become 4. Okay. Now, you can apply second operation and you can make it mark. But will it make any sense? Again, you cannot increase the points further. Okay. So everyone clear with the problem statement. And if you observe its second example, you are only having one enemy and your current energy is 10. So every time what it is doing, it is unmarked. So how many times it will happen? Simply 5 times. You'll get 5 points. Why? Because you keep subtracting 2 every time. This will become 8, 6, so on. Okay? Until it becomes 0, we'll apply these operations. So now let's see how we can solve this. So for solving, let's take a more better example than this. So let's consider this example. Let's say you're having enemy energies as 5, 2, 3, 4. Okay, let's keep it simple. And let's say these are the indices. Hmm. Now, let's see how we can solve this. Let's say you're having current energy as. What if, can you tell me one thing? If current energy is 1, can we move forward? Firstly, you cannot apply first operation because you don't find any enemy having less energy than current energy, and you're having initially your points are 0, so you cannot apply second operation as well. In this case, you should return 0. And let's say what if your current energy is 3? Now all the enemies are unmarked initially. Okay, and you need to pick how many enemies can you pick for applying first operation. Of course, 2 and so among this, what you will pick? You will pick the minimum. Okay. So you'll pick the minimum one, you will make current energy as 1 and you will increase your points to 1. Now you should apply second operation for sure. So for that, what you will pick? Will you pick 5, 3, 2, 4? Which one you pick? We'll try to maximize it. So can I simply say you will add 5 and you will make it marked? Yes or no? Again, you will try to apply first operation. And first operation, can you tell me like on which values you will on which values you will apply first operation? Will you pick 3? Will you pick 4 or will you pick 2? We'll simply pick 2. So this will make 4. You will increase the point. So this way until this becomes 0, you will do it. So how many times you will do? 3 times. So from 1 it will become 4. Now again you need to add energy. So which energy will add? You will add 4. Yes sir. Again you will get 2 more points. You will make it mark. By applying first operation, you will get 2 more points. Again, you will try to add this. It will become 0. And again, you will try to add 3. You will make it marked. So if you simply observe this problem, what are you doing? You are trying to apply second operation and all the values except for the minimum value. Yes, sir. And every time you will apply first operation on the minimum value in that enemy index. Yes, sir. So can I simply say if I know the minimum value, let's say minimum value of the energy elements, and also let's say I know the sum of all the array elements. Can you tell me what is sum of all the array elements? Simple, 14. Yes, sir. Now, can I simply say except for minimum, I am going to add all the values to current energy? Yes, sir. If my current energy is 3, so can I simply say except for minimum? What is that minimum? 2. So if I simply subtract minimum from sum, that is nothing but 2. I am going to add it to current energy. Yes or no? Sum minus mn. Now once I got this value and I add these two. So what happens? With the help of this current energy, okay, current energy and mi. This is the updated current energy, that is nothing but 15. And this is the minimum value. Based on this, can you simply tell me how many points can you win? How many times you can subtract 2 from current energy? Can I simply say it is nothing but current energy by minimum? Yes, sir. 15 by 2. So it will be nothing but 7. So what's our approach? Firstly, we need to calculate sum of the array. At the same time, we need to pick the minimum element from the enemy's energy. Okay. And we should subtract it from the sum. So we'll get some sum. Then for current energy, we should add this sum. Okay. So we'll get the updated current energy. Once we got this updated current energy and minimum, we can directly get our answer. Okay. So let's quickly write code for this. Now let's start writing code for second problem. So firstly, let's take size of an array into n. Okay, let me copy this. Main agenda, we need to calculate, we need to get the minimum element from the array. So how can we get it? You can take some variable and you can initialize to maximum value. Now, along with this, you need to calculate some. But if you observe, if you observe the constraints, what are the constraints? You will be length of the array is 10 power 5 and each element will go up to 10 power. Okay. So if you try to add those values, like let's say in the worst case scenario, you're having 10 power 5 elements and each element is 10 power 9. If you add all those values, it will exceed 10 power 9 integer range. Okay. So instead of int, let's take long. Okay. And let's simply start with current energy. Okay. Now let's start a for loop. So simply every time pick the minimum value. Also add the value to sum. Okay. Now once you got these values, this is what is the sum? That is nothing but updated current energy. But you need to subtract minimum from it. Okay. Now you are having this, but what's the condition we should be checking firstly before going ahead? That is, if current energy is less than minimum value itself, what should it? Should it is 0. Yes, sir. If it is greater than minimum value, simply what you can do, you can have some answer variable. And how can you get the answer? Simply updated enemy energy, that is nothing but sum here, divided by mn. So simply return answer. Okay, that's it. And the third problem is nothing but it's a modification of first problem. So what is the first problem? We are looking for alternating groups, continuous alternating groups of size 3. And here the modification is nothing but we should be looking for cases. Okay, it's the that's the only slight difference from the problem 1 and problem 3. Now let's try to understand this by using with the help of these examples. So if you observe the example 1, k is 3. That means it is nothing but it is same as first problem. Okay, let's directly go to example 2. Now in this example 2, what is the given array? Colors. It is nothing but this is the given array. Okay, and these are the indices. Okay, so now simply what is k? K is 6. Now you need to have the windows, like let's say previously we are looking for 3 contiguous elements. Now we need to look for 6 contiguous elements. Now let's try to see how many groups are there. So if you observe, if you start with index 3, you are having one group. Similarly, if you start with index 4, you will be getting another. Okay. So in total, how many groups are there? Two groups are there. Now, in this, now let's see how we can solve this problem. Now, let's say, since it is in circle, can you simply say after 6? If you start with 0, you will be having k as 6, right? So simply, you will be taking this width. Okay, you are taking 6 elements. Now again, if you are starting from 1, how many elements are required? From 1 to 6. Similarly, if you start from 2, how many elements are required? Since it is circle, you need from 2 to 6 also 0 index. Yes, sir. 2 to 6 and 0 index. If you are starting from 3, you need to have from 3 to 0 and also first index. Then 4 to second index, 5 to again third index, again 6 to fourth index. So simply, if you want to see windows from 0 to n minus 1, extra how many till where you will be going? Can I simply say till k minus 1 times? After 6, you are accessing next k minus 1 elements. Yes, sir, from 0 to 5. Sorry, from 0 to 4. So what we are trying to do is, we'll do something like this. Let's say these are the next elements. Okay. So simply, this is the modified colors of it. Now let's start with 0. Okay. We need to get the alternating groups of size 6. So simply what I will do is, let's take a data structure, and with the help of this data structure, we can perform these operations. I assume these operations can be performed on this data structure. So simply, I will have 0. Okay. First 0 the next value. Now I will move forward. I will insert. I will move forward. I am at 1. Now what I'll do is, I'll compare with the last element in this particular data structure. And if the current element is not equals to last previous element in this queue, I will simply insert it. Okay. Again, I will move forward. Again, I will compare with previous element, last element that we pushed into this particular data structure. Again, I'll move forward, and again I'll compare. When these both are equal, like current element and the last pushed element into the data structure is same, can I? Is there any point of pushing this particular element? Will this form a alternating group? No, right? So simply what I will do is, anyway, this is not going to form alternative. So simply when I'm here, I will clear the entire data structure. Okay, I will clear the entire data structure and I will insert this element. Okay, current. Again, I'll move forward. I will do the same. I will insert 1. When I'm at 0, again I will compare with the previous element. I will insert 0. Again, I'll compare. I will insert. I'll move forward. Now, if you observe, I'm trying to access 0th index file. Okay, I'm trying to access 0th index file since it is circle. Okay, so simply again I will compare. I will insert. So if you observe, again I'll move forward. I will insert. Now, if you observe at this point of time, you got one group. Okay, you have got a group of size k having alternating values. Yes, sir. So at this point, what I will do is, I'll maintain some variable. Let's say groups, and initially it will be 0. Whenever I got this data structure size as k, okay, simply I will increment this, and I will remove the first starting element. I will remove the starting element, and I'll move forward. Again, 0, it is not same as the last element that you pushed into the data structure. So again, I will push it. Again, if you observe, this is another, like again, this is the size equals to p. Again, I will increase this and I will pop this. Again, I will move forward. If you observe, the last pushed element is not same as this. So simply, I will clear the entire data structure, and again, I will insert this 0. I'll move forward. again 1, then you can stop. Okay. Now, can you simply tell me till how many times I'm traversing from where to where I'm traversing? Can I simply say if n is 7 and k is 6, you're traversing for n plus k minus 1. Yes or no? You're traversing till n plus k minus 1. Yes or no? That is nothing but 13. 13 minus 1 is 2. Okay. So if this is 12, you're traversing till 11. Is it clear? And can you tell me what's the name of this data structure? This is nothing but DQ. So either you can push or pop from front or back. Okay. Now let's quickly code it. So firstly, let's take array size colors dot size. Okay. Now let's take a DQ of type integer. Also, let's take some answer variable for, or let's take it as groups. How many groups we are getting, and initialize to 0. Now, initially, let's push 0th index element into DQ. So we should push from backside, and we are pushing colors of 0. Okay. Now let's start our iterations. So you'll be traversing from I equals to 1 to I less than n plus how many times? K minus 1. Okay. So every time simply what you should be doing, you should compare with the last element. This one. So firstly, if dq dot ban, if dq dot ban is not equals to current element, that is nothing but colors of I, then what you will be doing? You will push it. So simply can I say if they both are not equal, you will push it. Even if they are equal, you will push it. Just that if the previous element is also equal, simply you will clear the entire lake. That's the only difference. Yes, sir. After clearing, if the previously last inserted element and the current element are equal, you will clear DQ. Or else you don't clear it. But whatever it is, you will push the current element. So colors of current. Also, like I had a small question for you here. Now, every time you're trying to access I, but your array size will be having from 0 to n minus. But if you see here, we are iterating till n plus k minus. Okay. So once you cross n minus 1, what happens? It will throw you. So how will you avoid? So simply after n minus 1, you're trying to access from 0. So, what I'll do is I'll do something like this. J, every time I'll apply percentage n. So it won't cross n. Okay, the values will be in between 0 and n minus 1. And instead of 5, let's use J for accessing the elements. Okay, now let's move forward with the logic. Now you push the element into DQ. Now every time, what you should be doing, you should check if DQ dot size is equals to here. If it is equal, then what you should be doing? Firstly, you should increment groups. That's the first thing you should do. And then DQ dot front. Okay, sorry. Again, you need to pop the front element. Okay. DQ dot pop front. Okay. Now, simply by the end, you will be having number of groups in the groups like variable. Simply you can return. Okay. Let's quickly run this code. Let's run it. That's it. If you find this video helpful, please consider liking this video and share with your friends. And don't forget to subscribe to Smart Intelligence YouTube channel. Thank you.